Welcome again to another Maine GIS Users Group Virtual Lunch and Learn. I'm Patrick Cunningham. I'll be your host along with Judy Coley-George for this Lunch and Learn. And today's topic should be interesting. It's virtual reality and archaeologists, an immersive partnership for the ages. We have two speakers with us today, Emily Blackwood and RJ Perry, both from the Vemmi Lab is what you guys call it. And I'll let them explain more about what that is all about. Just so you know, they'll be both doing, each be doing a presentation. But at any time, if you have any questions, you can put them in the chat, and Judy and I will try to ask those of our presenters as they're going along. This is just a casual brown bag lunch and learn, albeit done over Zoom. So it's meant to be something where it's for your benefit, and we appreciate any questions or anything of interest that you want to share in regards to the topic at hand. Just a word on the Maine GIS user group. We are a nonprofit entity that is focused on promoting GIS education and awareness in the state of Maine. We've been around for maybe almost 3 decades. Is that right, Judy? I forget the year of inception, but we've been around quite a while, and we're surviving the pandemic, fortunately, and we're doing so by doing these virtual meetings. As you can see, in years past, usually we got together at different locations around the state for a couple of conferences a year and lightning talks and kind of mappy hour things, or even GIS day. So we're looking forward to getting back to the in-person stuff. Nothing like that is scheduled too soon on the horizon, though we are talking about maybe trying to do some sort of outdoor gathering in the spring or something. Until then, we're going to continue on with our virtual lunch and learn series. But you can get involved in MEGUG. There's a lot of different ways. Certainly, you could present your work. We're always looking for presenters for our lunch and learns, and I think that people sometimes think they have to have some groundbreaking topic or something that's completely unique. And although today's presentation is pretty unique for Maine, and it's a great one, don't be intimidated. Anything that you're working on in geospatial or cartography or mapping, we're interested in hearing about, and it doesn't have to be perfect. It doesn't have to be complete. In fact, we like to talk about challenges and mistakes and how we can learn from our work. So step up and present. We'd love to hear from you. Or you could also become a member. I think our elections are coming up soon, and I know that we're working on how we're going to do that. We'll have some information on that coming soon. I think they'll be around the November timeframe. But you can also volunteer to serve on a committee or a working group as well. I'm sorry, you can become a member, or you could run for the board. Those are 2 different things. We've actually got up there 3 in total: become a member, become a sponsor, or run for the board. Anyway, so lots of ways you can get involved, and you can see we have some of our top sponsors down here listed below. So we're very thankful for our sponsors and support that we get from all the companies and organizations that support us. Here are some of the committees and working groups we have that you could volunteer to join if you're interested. Education, membership, publicity, those type of things. Finance, bylaws and policy. Wherever you feel like you can contribute. The current makeup of the board as it is today: Andy Smith-Peterson is our chair, and Judy is our vice chair. And we have a few others from around the state that represent GIS entities and help from the day-to-day or the month-to-month stuff that we do. One word on our next Lunch and Learn next month. We're going to be hearing from Firuza Pavri, the director of the Muskie School of Public Service and also a professor of geography at USM. So we're really excited for that. Note that this one is not going to be right at noon. It's going to be a 1 o'clock time frame, just to work in everybody's schedules. So that'll be October 5th. And I think the registration information for that is on megug.org. So please join us for that event. It should be a good lunch and learn. And then, of course, we do record all these and put them on YouTube. And so you can, if you miss one that you wanted to see, you can go watch it there. Please follow us or subscribe to all of our social stuff that we've got online, or maybe the ones that you like. Maybe you're not a book-faced person, but you're okay with the Twitters. Either way, we hope that you will follow us and support us that way as well. So here's what I'll hand it over to Judy to do the intros.
Great, thanks, Patrick. We're super excited to welcome RJ Perry and Emily Blackwood. They're both gonna speak today. RJ is the technical coordinator at the VEMI Lab, has an associate's in electrical automation from Eastern Maine Community College, a bachelor's in electrical engineering technology from U Maine, and he completed his master's in spatial information science in 2017. Now he's a project manager and technical advisor at the VEMI Lab, and his interests are in software hardware integration that lends itself to research and development projects that the lab works on. So we're super excited to hear about how we're going to use augmented and virtual reality related to GIS. And then Emily is going to follow him, and she is an interdisciplinary PhD student at the VEMI Lab, and her academic interests include how humans have interacted with past environments and what we can learn from their behavior from an archaeological perspective. And she is working on her third degree from UMaine, having received a BA in Anthropology and an MS in Quaternary Climate Studies. And now for her doctoral research, she's focusing on reconstructing archaeological sites using virtual reality. So using virtual reality, archaeological research is still new to the discipline, but is a powerful tool and platform that has potential to allow archaeologists to examine sites through a totally different perspective. And we're really excited to hear about that. So with those introductions, I'm going to turn it over to RJ to get us started, and then Emily will follow.
All right, let's see if I can take control of the screen sharing. There we go. Is that working?
Yep.
All right. So, hi, my name is RJ Perry. I work at the VEMI Lab, and I'm going to talk to everyone today about using virtual reality and augmented reality as research tools. Skip that. So first off, just blurb about the VEMI Lab. So we're a collaborative research lab. Our director is Dr. Richard Corey, and our two principal investigators are Dr. Nicholas Giudici and Dr. Caitlin Howell. We have a pretty wide field of research that we cover, or a few fields of research, going from human technology interaction to blind and visually impaired wayfinding and other accessibility, to biomimetic materials innovations. We're not going to be talking a whole lot about the biomedical side today, but if you're super interested in that, Dr. Howell loves talking about her work, so feel free to reach out using the email addresses I have at the end of the presentation. So in general, we're a research education lab. We use experiential learning to teach our undergrads and grad students really how to perform research. So we have a pretty decent staff, around 24 students right now with 20 active projects. Each of those projects has a few students working on them, doing all the day-to-day tasks. So all the cool VR stuff I'm about to show off, the majority, if not all of it, was done by students. All right, so first off, kind of what is virtual reality? There are a lot of things that can be virtual reality, but generally accepted, it's 100% a digital environment, right? So you have to make the virtual landscape that you can explore. But not just the visuals, right? We have to deal with the soundscape and usually some amount of haptic feedback in like modern virtual things. The video that's playing now is a fun little demo we show off when people come to tour. We built the visual, like the landscape, right? This pirate ship that they're on. There's a soundscape. You can hear the waves and the wind. There's a little bit of haptic feedback when these controllers touch the rungs that you can climb on this ship, right? There's usually some amount of viewpoint manipulation. In this case, and in many cases around the lab, it's with a VR headset, right, where the orientation and position of the head is tracked, which gives you a first-person feel in these realms that you go to, right? But often you'll also see some that use like a tablet or a phone that are fully VR, and they just use orientation as you move the device around. So some amount of sensor manipulation. And often physical manipulation of digital objects. So the ability to, throw and catch a digital football, right? These are things that are not always in VR, but are very often in VR. So as mentioned in the title of my presentation, we use virtual reality as a research tool. So this is a very bare bones simulation, just a grid world, no audio, no haptics, very bare bone. But we're still constantly recording the position and orientation of the headset. And we have a timer running that we can record how long these simple navigation tasks take people. So this particular experiment has the participant walking to these orange squares, right? And then at the very end, they're going to be asked to look back at the position they started at to see if they were able to record their movement in this spatially agnostic world, right? And then once they look, it tells them up on screen how close they were. This is more of a demo thing. In a real experiment, we wouldn't do that, obviously. And then it shows them where they walked. So this is showing kind of all of the features that we very commonly use in our VR experiments. So you may have noticed, you may not have noticed that in that one, there was a bounding box that popped up occasionally when someone gets too close to the edge. That is something that we're constantly working with when we're doing VR worlds, because even though this world looks enormous, it's actually only like a 12 by 12 foot area. So we have to do a few different hacks to try to make the world feel larger. And in this one, we're showing the addition of a z-axis, right? So there's an elevator that takes you down to a whole second zone that feels, very different from the first one. And we can use this and a few other like rotation hacks to make a zone feel larger than it really is. In some experiments, we can just use what's often known in VR as teleportation, where you just kind of move through and teleport to different spots. But in a lot of the specifically navigation tasks that we like doing, you really can't do that. You need the person to be in control of their own locomotion. On top of virtual reality is augmented reality. The augmented really couldn't exist without virtual having existed first, right? So in augmented reality, you also have a user-controlled visual feed, not just the viewport that you're controlling in the virtual world, but in this case, you're actually controlling some real live video feed, often with an HMD, a head-mounted display, or through a phone. And there is usually some sort of keyed digital object that you are applying a digital overlay to. So this particular image that's up, we're using object recognition. So the keyed images or the keyed objects are the objects being detected, and then a bounding box is drawn around them with a label saying what we think they are. In some cases, you'll have QR codes, right, which are little tags you can put on a table, and then that becomes a keyed object that you can put a dancing bear on top of, whatever you want to use. And there's very often not interaction in augmented reality. Sometimes there is. I've seen some gestures where hand can tickle a little bear on screen or something. But often augmented reality is just overlaying this digital data onto the virtual video or the real video feed. So when we first started playing with augmented reality, we took what we already knew, right, which was virtual worlds, and added what augmented reality would look like into those worlds. So this is before the hardware really caught up so we could do real augmented reality. In this demo, we're showing off the edge detection that you can use to really accentuate edges of objects in difficult environments. So in this case, a fire is in the building. The room we're in is actually the tour room we show off at the VEMI Lab. And we're showing what would happen if we had, for example, a CAD model that we could overlay on the real world. So it shows the highlights of objects, chairs, walls, things like that to the person, which would really be helpful in a disaster scenario when smoke is clogging your view. We then took that same technology and used it with a real augmented feed. So in this case, we have stereoscopic cameras, 2 cameras side by side that are mimicking human eyes. And you put on the headset, and the headset overlays lines wherever it detects a difference between the 2 feeds, or a difference in the shading of them. So we're really good at getting edges of objects like stairs. We then went one step further and started our own object recognition and classification. So this one is one that was done by one of our students. It's not as comprehensive as you can see some object recognition builds online that you can download, because those have, whole crews behind them. That was just one student specifically looking at things like fire escapes, light switches, and coffee mugs. 3 different things that for various reasons would be important for a blind person, for example, to be able to find or know where they are. And then we finally evolved into doing full mobile augmented reality. I don't have a cool video of this one, but we worked with the nursing department to make a study aid for students that are learning remotely. And we did a small experiment with this that I believe just got publicized, was just published. And I don't have the publication information, but if you are all interested, I'm sure I can get that to the group. And anyway, so this app will overlay a heart on specifically on a QR code that is keyed to, that is scaled to be correct for a human. So this can be used for group work. You can have one person holding the phone and telling another person like the exact spots they need to press on the chest, for example, to chest test for tenderness. Or you can go through the education scenario, which is specifically congestive heart failure. It goes through some of the warning signs, some of how the heart interacts, and what you should do when these things are happening if you're a nurse in training. We did an experiment to see how this compared to a traditional learning environment. And basically the results were, it was almost as good for the testing results for the students who took the test studying with this versus traditional study habits, but it was much more engaging. They enjoyed it significantly more. So if we can take some time and make more of these style teaching aids, then we could really increase engagement in student learning. So those were some, the evolution of AR and VR and how we're using them in technology. And I also just want to talk briefly about a few of the GIS related technologies that we've used in a couple of demos and experiments over the past few years. So augmented transparency, this is something we worked with Sebastopol Valley Health when they were adding their new wing to the hospital. So they gave us the CAD files for their entire building, and we modeled it up originally to help with relocation trauma. So you could show this to someone who's going to be spending an exceptional amount of time here, and they get used to what their facility will look like in the long run. But because they gave us the whole CAD file, we decided to also implement all of the tubes and wiring and ductwork that's included in this type of facility. So the facilities and maintenance workers could really get an appreciation for what AR and VR could do for them as well. So we brought this over to show them, and they were ecstatic. They were standing in this exact room, and they'd turn on the AR, and they'd see that downstairs, the boiler's down there, and they'd run over through the stairs, go check it out, come back up. Real excited. This is something that we've been interested in doing in external environments as well. You can imagine using this with DigSafe to know very easily where pipes are underground, but there's some extenuating factors that make it more difficult to do outside. So we haven't really gotten that far yet. Wayfinding via external landmarks. This is an extension of some graduate work done by Hangshang Li, who has since graduated. But his work was using external landmarks, in this case, the moon and the satellite that's out there, to have a better understanding of spatially where you are in a complex indoor environment. So we took his work that he used for his PhD, and then we made a really cool space demo out of it that we get to show off and kind of talk about how his stuff worked. So in this case, we use that one of your hands has a basically an X-ray window bound to it that can see right through the walls and always see where the moon and the satellite are. So you don't get lost in this basically maze of a space station. Digital location recreation, which is something that Emily's going to talk about quite a bit more, but this was kind of the demo that we built when she was still a master's student that I think got her really interested in her current PhD work. This is showing on one of the rivers in Maine, these landmarks that no longer exist when the native tribes were, were everywhere on this land. They would have these giant refuse piles by the river that showed basically how large their tribe was, how much weight they carried around, specifically on how large these refuse piles were that you would always see as you were coming up the river, because the rivers were the highways at the time. If you have any real questions about this, Emily will be much better at talking about it than I am. Please direct them to her. She loves talking about this stuff. And then how am I doing on time? Yeah. So I also want to talk about some intriguing technologies that we've played around with at the lab, but we really haven't had any like funded projects for, but I thought you guys might be interested in. So passive RFID, something we've played with. It's a little bit of a dated technology, but it evolves into some of the things I'm talking about. But you can basically put these, 1 or 2 cent RFID tags on any object you want. And they aren't powered themselves. So they're powered by the reader that comes over to them. So you could put this tag on like a landmark that is important or a telephone pole that you want to keep data of. And when you bring the reader over to it, the RFID tag can pull up data within your software about this particular object. So you never lose that data. You're always keyed into the exact one that you're working at or the exact place you're working at. That has kind of evolved into these Bluetooth beacon technologies. So this wirelessly does very similar effects, but they're battery powered objects. So in this, you could imagine putting a Bluetooth beacon, for example, at the Lincoln Memorial. And then as people are, exploring that area and they walk close to the Lincoln Memorial, their phone could prompt them with, would you like to open this link? And it will be information about the Lincoln Memorial. Or you could do, internal objects instead of an external object that you want to keep that data about when you're entering an area. There's a lot you can do with this technology, and it is all very spatially related. We've tried using them for triangulation indoors, and they didn't work quite as well as we wanted them to. But I think they could be used for larger triangulation technology outdoors, which is what I wanted to talk about next, was Wi-Fi triangulation. So this is the same technology or the same concepts, whether you're talking about GPS or cell signal or Wi-Fi. You can, if you have a few different cell towers or a few different satellites or a few different wireless APs, and they're all broadcasting, and your phone or digital device can recognize them all, you can do some triangulation to figure out where you are. Externally, we generally use GPS for this, right? But GPS is only good for about plus or minus 3 meters, which is really good when you're driving down the road, but it's not so good if you're, for example, in a garden and you want to know about information about the plants in front of you. Or if you are trying to do a hedge maze, right? You're just not, you don't have enough precise information. The triangulation with wireless access points is a bit more precise than that, but usually requires the addition of some amount of machine learning to learn the common difficulties in an area. So things like walls inside of a building affect the signal strength as the signal either bounces around them or passes through them. So with a little bit of machine learning to recognize the specific ins and outs of a building, you can use these wireless APs to triangulate and do indoor Wi-Fi navigation. That's something we want to play with more at some point, although we've just kind of played with the technology a little at this point. And then I thought I should probably talk about my master's project, which I haven't done as much with as I should, but my professor constantly is reminding me that I should publish at some point. So my master's project was about tactile contour mapping. So contour maps or elevation maps are very common in the mapping industry. I'm not telling any of you anything new, I'm sure. But they don't really exist for the blind and visually impaired. A few alternatives exist, like 3D printing or some of the vacuum form molding of maps, which are really cool, but they're kind of cost prohibitive. So in the BVI field, these printers exist called tactile printers, which can print both specifically Braille dots for reading, but can also emboss lines and areas to add tactile differences and resistance to them. So my thought was, why don't we try to convert these contour maps into the BVI field using one of these Braille embossers? My results were very promising. So blindfolded sighted participants were very good at understanding what we were trying to show off by these elevation lines, recognizing slope and identifying, of 3 or 4 different 3D printed models that I made based on these elevation lines, which one matches with the embossed image. Blind participants were not as good, but I think it has more to do with my inability to teach really how to use contour and elevation maps. And I think with a little bit of extra work, this could be really, really useful in that field. So I really should publish this and get around to it. That's on me though. Anyway, that is my half of the presentation. Thank you for listening. If you have any questions about the presentation, in addition to any you may have presently, please feel free to email me with them. If you are at all interested in coming to tour the lab with yourself or with a small group, or you would like to work with us on a project through, a grant project, or maybe you have some money that you could hire a group to do something for you and you want to work with a university, please reach out to the director's assistant, Emily Hanscom, and she will schedule all of that. And just for general inquiries, please visit us at vemmilab.com.
Thanks, RJ. There's really interesting stuff. You can hand control over to Emily if you want. Well, we didn't have any questions. I think that maybe people are thinking a little bit and processing what you presented. But one thing that does come to mind for me in some of the work that we've looked at, internal navigation with the Wi-Fi signal triangulation stuff is kind of interesting, but no. In emergency management and military uses, that I don't think they would be able to do something like that, because they're in situations where maybe it's completely dark, or you don't, have you guys looked at any other kind of internal navigation stuff?
So a few things we've looked at specifically for emergency management. When we started looking at the augmented reality stuff, that was originally going to be emergency management. Either for edge detection for, again, a large smoke environment, or if we can get the actual CAD drawing of a building, and we can track the position and orientation of, for example, a firefighter's helmet, the same way we can track the position and orientation of a VR headset, then we can display that CAD drawing or a X-ray version of it while they're moving, right? So that could help them with that navigation. And then for other indoor navigation things, I mentioned briefly that we looked at using Bluetooth beacons for that. And it wasn't as useful as we had hoped. There was a lot of interference. Something I'm interested in with emergency management for triangulation is giving them what they need to do that, right? So rather than using internal Wi-Fi signals, having an access point or some other triangulation beacon specifically located on each of the trucks, right? So they generally would park, if they can get around a building, park the trucks all the way around a building, and that gives them their triangulation pattern they need.
Oh, okay. That's interesting.
So I'd like to look at that. There's also some amount that can be done with using the phones of someone who may be trapped as an iBeacon. Because that technology is built into their phone already. So if that is something that, for example, Apple or Android would allow emergency management services to turn on when these things happen, then the phone becomes a beacon that can be found. So
Cool. Great. Well, maybe we may have some other questions for you later on. So thanks for that overview. Now, I guess we can hear about how this would apply with archaeology research.
Okay.
Awesome.
Well, I am Emily. I'm an interdisciplinary PhD student at the University of Maine. I've been here for quite a while. I'm just started my 12th academic year, and I like to joke with my advisors that I'm just collecting degrees. But today I'm going to talk to you about virtual reality and archaeology and how VR can be a really powerful tool and platform to use to showcase archaeological data. So before I get into that, I would just like to draw attention to the land acknowledgement between the University of Maine and the Penobscot Nation. These types of land acknowledgements are the bare minimum that any university or entity can do, but it's an important first step in recognizing the atrocities that have been committed by white people in the past and present, as long as it's not performative allyship and there's follow-up action to it. Archaeology as a discipline is currently going through a really quite big social reckoning because it's historically been a male-dominated field full of inequity, racism, sexism, and white saviorship. Archaeology is a destructive process, and it has been harmful to Indigenous peoples, and it's really beyond time for that to change. There's also a memorandum of understanding between the Penobscot Nation and the university that outlines and goes over how the university will house and store and care for cultural material and cultural heritage. So what is archaeology? Hollywood has painted a very inaccurate picture of it through the portrayals of Indiana Jones and Laura Croft. Both of these characters are really, really harmful to the discipline, and they really cause a lot of harm to people. So archaeology is actually one of 4 subdisciplines of anthropology, which is the study of human societies and cultures and their development through time. And more specifically, archaeology is the study of human history and prehistory through the excavation of sites and the analysis of artifacts and other physical remains that are recovered from those sites. So just a couple of terms that I wanted to go over so that we're all a little bit more familiar with these as I use them throughout the talk. A midden is a pile, a mound, or a heap of shells, often mixed with discarded cultural materials. An artifact is anything that has been modified or made by a human, such as projectile points, or you might be more familiar with the term arrowheads, as well as flakes and sling stones. Looting is the illicit removal of artifacts from a site. This may be as simple as you're out on a hike and you look down and you come across a projectile point and you pick it up because you think that it's neat, or more deliberate in where you know that you're on an archaeological site and you specifically remove objects to keep or sell. Currently, there's only laws that pertain in the states that pertain to land that is federally owned. These don't pertain to what is considered private property. Calibrated years before present, or cal years BP, is used when you're referencing radiocarbon dating, and it refers to the years before present refers to years before 1950. Because that's before they started testing all of the bombs in the atmosphere that really messes with things. So what is virtual reality? RJ kind of went over this and described it. So just to briefly remind us, it's a computer-generated simulation of a 3D image or environment that can be interacted with in a seemingly real or physical way by a person using special electronic equipment. In my case and at the lab, we use HMDs, or head-mounted displays, which is shown here on the right. This is the HTC Vive, and this version I'm particularly thrilled with because it has, it includes headphones, which really allow to increase the immersion and interaction with a site. As well as having 2 handheld controllers, which you can use to navigate around and interact with the site itself. So archaeology and virtual reality separately each have their own set of ethical concerns. And when you combine these two, there are some like pretty serious ethical concerns that have to be considered when doing this type of research. The first is publication of cultural material. And really since the start of archaeology and when things began to be published and up until present day, this is often done without the consent of the indigenous people or the people who you're studying. Accessibility. This refers to, will this kind of research sit behind a paywall? Will it be open access? But that's only part of it, because oftentimes the people who this would really help don't actually have access to the internet. As well as looting, which I defined earlier. Looting has always been a problem. I fear that it always will be a problem. And I think it stems from a severe lack of education of how it can be incredibly harmful to remove someone else's cultural materials. Even if you own the property, that doesn't mean that you are entitled to or own someone else's culture. Intellectual property rights, because I'm a student at UMaine, they own everything that I do. And commercialization with regards to this type of research, it's a pretty thin line to cultural appropriation, which is profiting off of another culture. So RJ kind of showcased this project a little bit. It's really what got me started down this research path. It's during my master's, I worked with an undergrad in the lab and Dr. Alice Kelly and Dr. Paul Roscoe from Earth Science and the Anthropology departments. And their idea was to create a visualization for the Damariscotta shell middens. You might be familiar with these areas. I'm not sure how many of you are from around there, but these are really gigantic middens. They are like several meters high, like 10 meters high, hundreds of meters long, and hundreds of meters wide. These are gigantic areas that really lack a lot of cultural material like a typical midden would have. So these are unique in themselves in their size and their consistency. And they were really struggling to create a visualization for their colleagues when they were describing this area and describing their theories about what was going on here. So we worked with them to translate the archaeological data into a 3D visualization that would help showcase and get this data out there. So in doing so, I was able to use that as a case study for my PhD. Because I'm in an interdisciplinary PhD program, that means that I worked with a committee to completely design my own doctoral research because it doesn't fit in with any of the programs that are offered at UMaine. And in doing so, I was able to develop a 3-step process. So the first step is called data collection. And because the site that I'm using for my doctoral research is located in Peru, we were able to fly a drone over the area, which would collect the data that I would need to create the base model for my reconstruction, as well as using excavation data to incorporate into that reconstruction. So this top image here is an example of what a completed level in an excavation unit looks like. This is a 1 by 1 meter square. And the bottom image is a representative of what a wall profile would look like. It might not be super visible here, but there are black lines that separate out each different level of this excavation. And the idea here is that by having this data, by capturing this data, I will be able to incorporate it into the virtual reconstruction, and you'll be able to excavate through the layers as I did. The next step is data processing. So during the excavation process, you really lose the 3D context of it because all of the data is recorded through photographs or level sheets or maps or field notes. So you really lose that context. And I need to take that now 2D data and put it back into its original 3D context as accurately as I can. Archaeology is a notoriously underfunded field. So oftentimes when data is published, it ends up being in grayscale or black and white because color images are really expensive to publish. So an example is this image here on the left. That is from the top of the site, and you're really heavily reliant on the caption to even like gain any idea of what's going on here. The map that's here on the right is a little bit better. You get some elevation data from the mountains that are around it, and spatially some ideas of where sites are in reference to each other, but you can't really gain any kind of visualization in your own mind. So in doing so, by taking that now 2D data and putting it back into its original 3D context, you can create a virtual reconstruction, which ends up being a 3D simulated version of that environment. So like I said, the site that I'm using for my PhD research is located in Peru, and it's known as the Ostra Collecting Station. This site is pretty unique in itself in that it's represented here by the upper right star. That's the Ostra Collecting Station. The lower right star is called the Ostra Base Camp. And now these are sister sites that are related to each other through radiocarbon dating, as well as diagnostic artifacts. And what I mean by a diagnostic artifact is that there are artifacts that are found at both of these sites that have not been found at any other sites in the surrounding region or really along any of the coast of Peru. So we know pretty definitively that they were inhabited by the same people at the same time. What makes it interesting that is if we can, I hope you can see my mouse here. We're kind of starting in the top left corner of this image. And if we follow along here, this is the outline of the ancient shoreline. And what that means is that when these sites were occupied, roughly 6,000 to 7,000 calibrated years before present, the ocean, which now sits 5 kilometers to the west of the sites, was actually located right adjacent to the sites. So already we're struggling to create an actual visualization in your own mind of what this area looked like and what these people would have experienced when they were living there, because the ocean was right up next to it. And now it's separated by 5 kilometers of desert and beach ridges. To kind of help you visualize what that is like, this is an image that's taken from the top of the site. The Andean Mountains are here to the east. The ocean would be behind us to the west. And this whole area on the right is a stranded embayment. So when it was occupied, the ocean would have been located all up in here. A couple of other images to help showcase this. This is looking out towards the west, towards the ocean, and you can't even see it on the horizon. And you're just surrounded by desert. It's really, really hard to even imagine what this area would have looked like when the water was right up on here. The image here on the right is I'm standing further out in this stranded embayment looking towards the site itself, which sits right up here on this ancient sea cliff, which is about 15 meters above the base of the site. So when you're using VR, sometimes you can use it to, as RJ was talking about, you're just creating an area to show different aspects of what you can do, like with the ship that he was climbing up. But when you're using VR to reconstruct an actual real physical place, you have a responsibility to make it as accurate as possible. And that's kind of what all of this is showing. This is just a flow chart of all of the data that we have available for the site that I have to then incorporate into this reconstruction. And there are 4 points that are really interesting, at least archaeologically to me. And that's the presence of pearls on the site, because pearls, and this is well documented in the archaeological record and the ethnographic record, and even in present day, pearls are very coveted like objects. They're very, very highly valued. And that plays into the presence of defensive site. This is hypothesized to be a defensive site. And not only just a defensive site, it's hypothesized to be the earliest defensive site in the Americas. So either in North or South America. If the dates that we are currently having out and being processed for these slingstone piles come back and are similar to our radiocarbon dates, this will be the earliest example of defensive mechanisms in the Americas. So that by itself is really quite unique and quite important. And what I mean by a slingstone, they can often be football shaped like here, or they can be more of rounded, like more fist-sized rocks that would have been used in slings. to aim towards people who are be trying to attack you. A third thing is the presence of the mollusks that have been recovered from these sites, and the analyses that have been done on them indicate that the climate for this area was vastly different when the sites were occupied as it is today. And perhaps one of the most important things is this, the presence of a structure on the site. So there is a 9 by 8 meter granite stone structure that sits on the top of the site. And for the time period that these areas were occupied, again, 6,000 to 7,000 calibrated years before present, that is considered monumental in size. That is an incredibly large structure for the time period. There's no other structures from any sites around this region that match that size at that date. So I think that some of the really incredible things about using VR as a platform for archaeological data is that you can do so much more in a virtual world than you can in the real world, especially during your field season, which is often incredibly short, usually 1 to 2 weeks. Maybe you get lucky and you get to be there for a month, but often that is not the case. And when we went to excavate this site, we were there for 2 weeks in July. And you can't really gain any kind of understanding of how the angle or the direction of the sun really would play into this site. Since it's considered to be defensive, the angle of the sun, the direction of the sun is something that really needs to be considered, because will that have any negative impacts on the defenders of the site? Would it create any blind spots? And if it does, who does it create it for? The defenders, the attackers? And even with the moon, does that play a role in this? And in VR, you can control for and you can manipulate those aspects to see and test if those actually played a role in it, as well as body height. That's a really important thing to consider, because I myself am 5'9", but ancient Peruvians and even modern Peruvians are much shorter in stature. They come in around 5 feet on average. And my own line of sight, my own line of vision is going to be very different than someone who's like 5 feet tall. So in VR, you can control for that and really kind of experience more accurately, I think, how these people would have experienced and viewed their landscape during the time of occupation. You can also, we can play around with and kind of try to determine which direction of attack they were expected from. Now, all of the data we have so far indicates that they would be coming from the north, especially since the base camp is located to the south of the collecting station and the related sites. So we do believe that the collecting station acted as a defensive outpost in the way where it was lined up to protect the base camp. But we don't know that for sure, and we can't find that out for sure until we look at the angles that the ancient sea cliff is at and which side would be more reasonable to have attacked from, whether they were coming from the south or the north. And so before I just show you my simulation, I just wanted to acknowledge my field team who helped me out in the field, as well as my committee back home, the VEMI Lab and Dr. Judici, who my assistantship is through, and the 2 entities that we got funding for in order to do this research. So I am going to, I think I have to switch my screen sharing. I want to show this one. Okay, so this, I'm using Unity to reconstruct my archaeological site. And here, what we were looking at is you're standing at, I have a little guy here who is set at 5 feet high, again, so try to look at it from a Peruvian, through the Peruvian eyes. And we can see we're standing at the base here. Up here is the granite stone structure, that 9 by 8 meter granite stone structure. So if we pop up there, and bear with me, I really hope you don't get motion sickness from this. These are the Andean mountains that are located to the west of the site. These aren't a fully accurate representation of it. I've tried to use a bunch of different programs to get it in here. I've tried to use Terrain Party, but it doesn't come to the right scale. So I just have mountains in here as placeholders that represent the Andean mountains, but are actual accurate depictions of what they are. And so we look around here and we're going to look from the north. So we're headed, you're looking towards the north. And if you remember those slingstone piles that I mentioned, so there are two lines of them. One sits along here, along this ridge. There's about 50 piles. And there's a second line that starts out here where that little black spot is and continues around this way for about another 50 piles. And there are several hundred stones within each pile. And ethnographically, archaeologically, there aren't really any other explanations to why these piles would exist other than being defensive. This is a representation of that granite stone structure. It is by no means a final product. Nothing in here is a final product at all. It very much needs to be upgraded and made much more presentable. But this whole area, this is where we flew our drone over. And this is how we were able to create this base model of this area. And what I think is probably most effective, one of the most effective aspects of this simulation is, so this is where the ocean actually was when the sites were occupied. This is a delta that has formed recently, so the water should be going over it. That's a thing that we need to tweak and fix. But really, when they experienced the site, when the sites were occupied, this is what they would have viewed to their east. And if we turn the water off, this is what it looks like in present day. It's really hard. The ocean is way out here. It's really, really difficult to, even when you're there, and I was physically there, to imagine what this looked like when the ocean was there. But in VR, you can put the ocean back in and you can gain a better understanding of the context of this site. So with the ocean having been where it's located, it really only limits access to the site as either from the north, coming this way towards the site, coming over the mountains, which is quite challenging and not thought to have been done, or you're coming from the south and the base camp is located just about here. So there's really only 3 access points to the site, whereas in present day, there's 4 access points, and there's a lot of work that's left to be done in this reconstruction, but I think it's a good first step, a first indication of like what you can do and the types of things that can be done. And looking at the time, we have 5 minutes. So I am going to say thank you and stop sharing in case there are any questions for either RJ or myself.
Thanks, Emily and RJ. Those were both spectacular. I just feel like I could never learn enough things in life. When I see things like this, I'm like, oh, that would be so cool. Well, I guess a question for both of you are, what have been some of the, especially GIS related technical challenges that you've faced? And I know, Emily, you mentioned a little bit about bringing in 3D information and getting it accurate. So maybe a little, either one of you have thoughts about, what are some of those challenges that we can all work on?
I know one of the issues that we were working on a bunch a few years ago, but we haven't had any recent projects related to it, but specifically trying to overcome that 3-meter offset with GPS. Trying to do that for a variety of reasons, but trying to find a better tracking mechanism than just using GPS constantly.
Yeah.
Yeah, I run into resolution problems. That's mine. We did, this excavation was done in 2019, pre-COVID. And the drone that we used, it allowed us to get this base model, and when you zoom out, it looks quite well, but when you zoom in, it's not great resolution. It's not where we wanted it to be. So I have ground level photos of the same grid that I'm going to incorporate into what we call a skin to overlay over this to kind of help like add to the accuracy of it. But it's quite a struggle. And it took a few GIS courses several years ago, but I had a really bad concussion at that time. So I don't quite remember as much as I would like to. So I really, really need to refresh myself on that, because I think it's going to be hugely beneficial to this type of project. I just haven't gotten there yet. Life has really gotten in the way. But
it always does. It always does.
Huge.
Well, you know, there's resources on campus, certainly at UMaine, that can may offer some help. The Barbara Wheatland Lab, they're doing a lot with drones. You may already know Tony, guy over there.
Yeah, no, there's a lot of work to be done. I ended up starting my PhD work while I was finishing up my master's. So everything kind of just got all mixed together and pushed off a little bit. So I just haven't had a time that I would like to really delve into this, but I know there's huge potential for it, and I'm very excited.
How about on the human side? How do both of you deal with like expectations of people, right? Like, so I know, like, we've done 3D modeling for quite a while, and you know, we always, so like even back in the 2000s, like early 2000s, I was doing some stuff, and you know, the comment was, where are the flowers by the mailbox? You know, and I'm like, okay, you realize the computer is about to die with what I put in here already, you know, so managing those expectations of people.
We really only have those issues with when we do younger like student tours, like high schoolers, right? Because they're used to video game graphics.
Yeah.
And everything, you know, that we've shown off today has had, you know, less than 3 developers working on it. Right. And in almost no amount of time, you're going to put that many people on a project is going to come out looking like, you know, a AAA video game title. So that's really the only time we have issues with that. We've noticed that when we have, you know, adults in here that are looking at these things, they're very impressed just by how immersive even a fairly simple environment in VR can look.
Mm-hmm.
So.
Great.
I run into it a little bit more of, they expect, I've presented this at several archaeological conferences, and they expect a very finished, polished project. It's like, this is a relatively new technology to be applying to this discipline, and there's a lot of data that we don't have. Like, I don't know anything about the plant species of this area during that time, so I'm not going to be able to incorporate that. Yeah. But once we gain that, I'll be able to add that data in. That's one of my, like, really, I really like VR for that, because you can constantly manipulate and add data as you gain more data, as it becomes more available. So it's just like an ever-growing project.
Well, even creating, I mean, certainly that's a great point, but also even just creating the mountain range behind your site accurately, that is not easy to get as mapping data. I'm not sure what mountains did you say that was?
It's the Andean mountains.
Yeah. You know, there has been LiDAR in the White Mountains and parts of, you know, in New England. I'm sure there hasn't been down there, or and then other ways you could do, you know, traditional mapping if they were surveyed, but then you know, it just, and I could walk you through how to try to recreate that with certain software, but that's a big challenge too, just that.
Yeah.
And who knows, there may be some passes in the mountain range that you're not seeing. Or the other thing too, is I was thinking about is watersheds, and how that has changed or not. But it's really interesting stuff. I thought it was a great presentation. I'm so glad you guys could share that with us. I don't know if you have any other questions, Judy, or
who's watching have any questions?
I haven't seen any come through yet. Doesn't mean that folks didn't like the talk.
Are all blown.
Yeah.
Yeah, everyone, I think.
Oh, hello?
I think we lost her.
Oh, well, someone said no questions, but very interesting. Thank you, Rosemary. Yeah, Emily seems to have frozen. But it's definitely great stuff. And so you did say, RJ, that you guys do tours, so people can come tour the lab if they're even if they're not a student.
Everyone, I don't know, with the invite.
Oop.
Oh,
We lost you, Emily. You just came back.
Emily.
Oh, okay. I was like, I think everyone's frozen and I don't know if it's me.
I was just asking RJ about tours of the lab. Is that something that's available to the?
Yep.
maybe not
Yep.
COVID
So we
time?
do tours. Basically, you just reach out to Emily Hanscom. If you go to our website, VEMILab.com, then there's a link right in there to like request a tour. And feel free to do, if you schedule a group tour of like, 5 to 10 people, that's great. We can do more than that, but it'll take us a little bit more notice, right? But yeah, no, we're really excited to be open up for tours again now that, some of the COVID restrictions have been lifted. So.
Excellent. All right. Well, thank you so much, everybody. We'll post the video on YouTube, and again, if you have any other mapping challenges and you're not finding help at U Maine, shoot us an email at megugboard@gmail.com. We can refer you to folks that might be able to help if possible. So
awesome. Thank you so much.
Thank you.
Thanks so much for sharing your work with us. We really appreciate it.
Yep. Thanks for inviting us.
Absolutely.
All right.
Thank you.
Take care.
Bye.
Bye.
Bye.